Warm welcome to you all. Thanks for joining today's session. Today we'll start with the exciting topic, the natural language processing. So as part of today's session, we'll start with understanding what is natural language processing in the case of artificial intelligence space, and why natural language is processing. So why it gained a lot of popularity, why most of them now they started in the enterprises they started focusing on the NLP space, and followed by that we'll explore the evolution of how the NLP got evolved over a period of time, and then we will move ahead and take a look at the NLP pipeline overview and then the text processing technique. Okay, the text processing technique is part of your NLP pipeline. Anyhow, we will start with natural language processing now. The first thing first, what is natural language processing and why natural language processing is required in the first place, right? So it is a subfield of natural language processing is a field of computer science, and it gives the computers the ability to understand and process human language. It is a subfield of your artificial intelligence and machine learning. Remember this, okay? So like how you be human. So it's something like in the case of self-driving car. Now, with the help of the machine learning, we are able to give brain to the car. Now the car can decide when to stop a car, when to take a diversion, and when it has to prepare to stop the vehicle. If something crosses the road out of the blue, how to react without human intervention. The system, in this case, the system is a self-driving car. It makes the decision on its own. Okay, without the presence of the driver or any human intervention or any remote control, it takes care everything on its own. Likewise, when you ask any questions, by typing the text, the system can now understand the artificial intelligence, which is nothing but the NLP systems now, right, can understand your queries and it can give you the appropriate answers. Especially after the emergence of large language models, it's really made our life more simple. It is a super cool language. Which one? The large language models. It's a subfield of artificial and machine learning, and it gives the computer the ability to understand and process human language. Now the systems can understand the human language. Whatever we type, it can understand, and then it can answer the questions in a natural way, how a human can respond to other person. Next step, you might be asking those questions. Okay, what is so big deal about it? What are the applications of natural language processing? So it has a wide range of applications. We all know, right? So with NLP, you can summarize the text. For example, you are given huge corpus of text data, and you want to understand the gist of all the documents. You don't have time to go through each and every document. You want to get the gist of what all those documents contains in it. Okay, so it's all unstructured data. So how I can extract, how I can convert them to structured data, and how I can extract the gist of the all the documents, right? So that kind of situation, the text summarization, we can do it as part of NLP. Next one is sentiment analysis. So in this case, it helps us to understand the sentiment of a piece of text, like whether it is a positive sentiment, negative sentiment, or neutral. The customers' reviews, for example, nowadays customers, they are exposed to all these social media websites, sites like Twitter and Facebook and so on, right? So in that case, customers feedback about your products or services or your competitors' products and services, whatever they posted it there. Is there any way I can understand what is my competitors' potential strength and weaknesses, right? So if you want to do some kind of SWOT analysis, you can use these customer reviews. With these reviews that are available in various social media sites, you can understand why customers are running after your competitor's product. Okay, and what is the gap with respect to the service or products you give it versus your competitors, right? Versus your competitors. You can do that kind of analysis. So the sentiment analysis, you can understand the positive sentiment or neutral or negative sentiment about your product. With that, you can understand the pulse of your customers about your products and services. And the NLP is rapidly growing field, right? So it will have an increasingly profound impact on our lives. So chatbots and virtual assistants also now gain a lot of popularity. It literally replaced the virtual assistants. Okay, you don't have to hire staffs to manually sit next to the system to answer to the queries raised by the customers or patients or other customers, right? You don't have to hire so many staffs. And again, across the globe, with different time zones, making these physical agents to sit and respond to each and every customers better. You can develop a chatbot. It's a virtual kind of a virtual assistant. Okay, so with chatbot, you can replace your physical agents. It can answers to the queries by the public or anyone when they start querying this chatbots. Okay, chatbots and virtual okay, it's no the computer. So it's a kind of a computer program. Okay, it's computer program. It can simulate conversation with humans, and so the chatbots nowadays are used in a variety of applications like customer service. Even in the case of education, healthcare, it is used. Okay, and question answering. Next one is the question answering. So I don't have to tell, right? So you know what is question answering. If you ask any questions, it gives you the answers, like how a human can give that, more than how a human can give the answers to your questions. It can give more information than a human can give, right? So the question answering is possible now with NLP. And next one is speech recognition. Speech recognition. Now it can, you don't have to type the queries. You can also enable this speak recognition feature, and then you can start talk and it can answer your queries, right? It can answer your queries like how a human can respond if you ask a question with him, right? The same way you can implement the speech recognition algorithm. It's all possible because of the natural language processing. Apart from this, the topic modeling and topic segmentation, also you can do it with natural language processing. Okay, anyhow, we will take a look at each and every applications as we move further. Now let us dive into the history of natural language processing. So it's the history of NLP. If you see, it's a fascinating journey. It spans several decades of research, development, and breakthroughs. Guys, believe me or not, right? So it has been started since 1960 itself. It was something like the roots of NLP, right? You can trace back to the early days of your computer science and artificial. So there is a gentleman called, a researcher called Alan. I don't know his full name, and Claude, Claud, Claude and Alan. They laid the groundwork for thinking about machines and languages. Is there any way we can make the system to respond to the customer queries in the form of text? Okay. And then what happened in 1960 and 70s, right? There is something called rule-based systems came into picture. And right, so this marked the initial attempts to use formal grammars and rules to process and generate human language. So I guess all of you guys are familiar with ELIZA, right? ELIZA in 1966 or so, they demonstrated basic conversational interactions with ELIZA. And then 1980 to 1990, there is something called knowledge-based NLP. Okay, so in this era, they saw the emergence of this one. So where the linguistic databases and expert systems were employed to handle the more complex language tasks. And I don't know how many of you are aware of this one. The projects like SHRDLU. Okay, that was focused on understanding and generating natural language commands. SH. Oh yeah, I'll write it on DLU. You can also do Google. Okay, if you are interested. But any of these are all. Oh yeah, I think now I am audible. Yeah, yes, yes. Thanks for the confirmation. Okay. And okay, let's move on with the 2013. Okay, between 2000 to 13, what has happened? Is someone missed out? 1 second. 1 second, yeah, some audio. Yeah, I was talking about this one, right? Knowledge-based NLP. So 1 second, yeah. It was painful. I think something went wrong with my audio. Okay, it's good only now. Cool. So knowledge-based NLP, and around between 1960 to 70, the rule-based systems. It started with rule-based systems, and then it moved towards this one, this feature knowledge-based NLP, and statistical NLP also gained popularity. Okay, so they have used the probabilistic models like Eden Markov models and N-grams. So those were, the statistical models paved the way for more sophisticated language processing. Okay. And then in 2000, year 2000 onwards, we could see that the machine learning and Corpora coming into picture. They started using SVM and then the conditional random fields. How many of you heard about the conditional random field? Right, so they use those kind of things to implement them. And then what happened in 2000? Sorry, here. Yeah, in 2014 onwards, the sequence to sequence and attention mechanism gained a lot of popularity. Okay, it literally revolutionized the machine translation and sequence generation tasks. Okay, this paved the way for neural machine translation system. If you want to translate from one language to another language, right? So these kind of algorithms were really played an important role. And then 2018, transfer learning and BET. What is BET? BET stands for bidirectional encoder representations from transformers. It demonstrated the power of pre-training language models on large corpora, large text data, okay, and fine-tuning them for specific tasks. Okay, this made a significant advancement in your contextual, what do you say, the language understanding. Okay, so which one? The transfer learning and BET. Okay, and the next one is 2019 onwards, we could see a significant breakthrough in the NLP space. The development of increasingly larger and more powerful transformer-based models such as GPT-2 and GPT-3 brought about a new era of NLP. Okay, so these models, which models? GPT-2 and GPT-3 exhibit the impressive language generation capabilities, making strides in areas like text completion, question answering, and even creative writing. For example, if you go to Chat GPT and if you ask him to write an article, it writes it, right? It's all possible because of the models, transformer-based models like GPT-2 and GPT-3. Okay. And also now the ethical and social considerations also came into picture now because of a lot of ethical related issues. Now along with these things, now they started focusing on ethical and social consideration also. Okay, so the Hugging phase and beyond, now LLMs and transfer models and Hugging phase, and even Hugging phase is kind of a transfer model. So these are all called large language models. Okay. What is that? Yeah, question from Deepika. She's saying, what is Lang 3? Yeah, lang chain. Sorry, language chain. There is no language chain. Any of that also now it is available. Yeah, I did not include the lang chain. So LLM and lang chain also now gain a lot of popularity now. We'll discuss that later point in time. Now let us take a look at the GPT-3. Before we dive in here, let us first understand what is LLM, large language model. What do you mean by large language model? Can someone tell me? What does it tells us? See, this, yeah, you are correct. So the LLMs are built using deep learning techniques. So you are correct. Yeah, it trained on huge amounts of text data and learn the pattern structure of the language. Fine. So the term large language model typically refers to the size of the model's architecture and scale of the training data. Scale of the training data, which means they train the models with the humongous amount of text data. Okay, the development of, especially after the emergence of large language models, it made a significant advancement in the field of NLP. Tasks include text generation, translation, summarization, sentiment analysis, question answering, and so on. Okay. Yeah, like I said, yes, you are correct. Deepika, you are correct. So what she says is, GPT is OpenAI's product. They trained this OpenAI with humongous amount of data. Correct. That is what I said. Okay. So these models, the large language models, are it's all it is also called the GPT. What is GPT? GPT stands for the classic example for the LLMs, or like large language models, are like transformer models. Transformer models are nothing but your BERT and GPT. What is GPT stands for? Generative pre-trained transformer. Okay, one second. I'll just write it here. Generative pre-trained transformer. So as the name itself consists of transformer, so we can conclude these are transformer based models. Which one? The GPT also. So now other question is, does GPT developed by OpenAI? Yes, GPT algorithm, right? It was developed by OpenAI. One second, I'll write it here. What is GPT? GPT stands for Generative Pre-trained Transformer. Pre-trained Transformer. GPT. Okay, it is developed by OpenAI. OpenAI is a company, so they are the one the developments. Okay, so the GPT models were pre-trained by humongous amount of data, and these models were trained with 13 billion parameters also. 13 billion parameters. What do you mean by parameter? How many of you know? See, guys, I believe that most of you are in this session are already familiar with what is machine learning, what is parameter, what is hyperparameter. What is the difference between parameter and hyperparameter? I believe all of you are familiar with it. Anyhow, the parameters are something like the value for the parameters are estimated by the model algorithm itself, whereas the hyperparameters, that is the one keyed in by the machine learning engineer like this, right? So the classic example is in the case of neural network. How many input neurons are required? What is your output layer neurons, number of neurons, and the hidden layer, how many number of neurons are required? So all the things you specify, and then what kind of optimization algorithm that needs to be used, everything you specify. So once you specify the values for these parameters, as part of your hyperparameters, the so-called hyperparameters, right, which are nothing but the number of input neurons. These are all your things. Sorry, not the number of input neurons, so the hidden layer neurons. Okay, hidden layer neurons and output layer neuron, right? The hidden layer neuron, you want to find out how many number of hidden layers are required, how many neurons are required, optimal number of neurons, right? So we cannot blindly have very large number of hidden layers, and each hidden layer, if you have so many neurons, you cannot blindly have it. You cannot go by your intuition. Rather, you want to find out the optimal number of neurons, right? So in that case, what we do is it's kind of a trial and error to determine the optimal number of neurons in the case of neural network. Even in the case of tree-based algorithms, how many number of trees are required, right? So number of trees, n estimators, they call it n estimators. You give some randomly some values. The model will go and fit with the different values, whatever you specified it. And with which value for the n estimators, the model accuracy is really good. Okay, just because you can create as many trees as you can, but at the end of the day, it should not slow down your training. It should not take more time to train your model, right? So with moderate amount of trees itself, you are able to train your model within the stipulated amount of time. It is good. But how do you know what is the optimum number of trees that needs to be created? That is where we use something called hyperparameter tuning, right? So here in this case, 13 billion parameters, they were having it here. So the GPT-3 is having these the key features, like it's all pre-trained and fine-tuned. Okay, it's all pre-trained on massive corpus of text data. Yes, Soundarya. Corpus is kind of, you just think, it's all article, or the huge amount of text data. Okay, so learning grammar, syntax, semantics, and even some degree of word knowledge. Okay, so it's all trained by someone else. Which one? The transformer models like a GPT and all, they trained with humongous amount of text data, everything. All you need to do is just you take that trained model, and then you can retrain with your existing data. For example, you are working in a healthcare project. You know very well, in the case of healthcare project, the data are highly secure. Though a healthcare service provider offices are located across the globe, each location, for example, in the case of US itself, right, across US, they have the healthcare provider, they have their healthcare center, but each healthcare center is data is completely different. It's all maintained independently from other locations. It's all highly secure in the case of USA, okay, to my knowledge. Okay, so in that case, you have a pre-trained model. Take that model to the data. You cannot take the data to the model. See, in the case of e-commerce, what we do? So we have let's say you have AWS EC2, and all the data, you put it in a single common place, and then you train your model. Your job is pretty simple. But even, pulling the data from other system and putting it in a unified environment is not that as easy. But in that case, what happened? You take all the data in a single place, put it in a single place, and then you train your model. Whereas in the case of healthcare, you take the model to the data. For example, you have Minnesota. In Minnesota, you have healthcare center, right? You take your model. Your model got already trained by your other location, Cincinnati or somewhere. So now you take the same model and go and train your model against that specific the healthcare center. Okay, it's not that you can keep all the healthcare in a common place. So this is typically different. This is a typical approach followed in the interest of maintaining the security and confidentiality. Okay, so in that kind of situation, right, they use the pre-trained models. Okay, pre-trained models. So even the case of NLP, the GPT. So because you cannot afford to train humongous amount of data, you don't have time and you don't have the environment, right? So you need a lot of GPUs to train the model. You don't have the infrastructure, everything. It's all pre-trained and fine-tuned also. Okay, you take them, and then probably you want to create your conversational AI. You can take them, and then let's say in the case of healthcare, it's a conversational AI, you want to build it. So in that kind of situation, you take the pre-trained model, and then you can, because the healthcare data are very secure. So what happens, for example, in the case of chat GPT, if you take the chat GPT and train your model, if you ask questions, everything, it's all highly secure. What happens is you are exposing your internal data or patient's data to the outside world. They don't want to happen that way. So in certain, now a lot of plugins are available as part of GPT, and we'll discuss that later point in time. Okay, so at this moment, guys, you remember that LLM stands for large language model. Especially after the emergence of LLMs, now we could see that we could make this significant breakthrough in the space of question answering and sentiment and so on. Okay, And also it has a multilingual capabilities. Okay, many large languages, right? It can understand, generate text in multiple languages. So it makes this versatile for a global audience. Okay, and the limitations, yeah. Now Soundarya asked, what is the limitations? So despite their capabilities, right? So the large language models have limitations, like sometimes, right, it generates incorrect or biased content. It is sensitive to input phrasing and lack of genuine understanding beyond the pattern recognition. Again, it has its own limitations, but compared to the pros and cons, it outweighs the um, once. Sorry. What is GPT-3? Generative Pre-trained Transformer 3. So this is one of the largest language model developed by OpenAI. Okay, it has close to, sorry, it's not 13. I think it's 175 billion parameters. Yes, you can also do Googling. It's somewhat closer to 175 billion parameters. And it can perform many tasks. So if you want to generate the text, for example, you want to write an article about a specific topic, it generates the text like anything. Okay, and translation. If you want to do the language translation, that is also possible. Text summarization, everything is possible with GPT-3. Okay, and into they'll ask you what are the pre-trained models or the large language models are available. Yeah, you already mentioned 175 billion parameters and can perform text generation. Yeah, all the things are possible with this one. The next one is the BET, bidirectional encoder representation from transformers. Okay, it is developed by Google. So it is another popular LLM. Okay, it has been trained on, again, the massive, humongous corpus of text data. So it can understand the context of sentence and generate meaningful response to questions. Okay. And apart from this, we have something like ExcelNet. This is developed by a university called Carnegie Mellon. Okay. So it has achieved the state-of-the-art performance of language tasks, including language generation and question answering. Okay, the ExcelNet. And next one is text-to-text transformer. Okay, 1 second. Pradeep, I will answer to that. So Pradeep's question is, of all these, which one is better? Okay, so we cannot generalize. Wait, I'll tell you. So next one is the T5, text-to-text transformer, transfer transformer, text-to-text transfer. Sorry, here the transfer is missing. Text-to-text transfer transformer. This was developed by Google. So which all things were developed by Google? BERT was developed by Google, and T5 also was developed by Google. GPT-3 was developed by OpenAI. ExcelNet was developed by the Carnegie Mellon University. And also Google uses a novel approach to language model called permutation language modeling. Okay, there is something else called permutation language modeling. And text to transformations, like translating text to another language. Okay, and creating a summary and question answering. So with all these things, you can do the text generation, everything. Or okay, now you might got confused. Which one is better? Before that, let us discuss another LLM models. See, Roberta. So robustly optimized better pre-training approach. This is developed by Facebook AI Research. All these giants, Facebook, Google, right? So they have their own, the version of the models, pre-trained models. Okay, the Roberta is an improved BERT version. So BERT was developed by Google, and so the Roberta was developed by Facebook AI, but it is an advanced version of the BERT. It performs better on several language tasks. Okay, so that is how it gained popularity. Which one? The Roberta. So now to answer to the question, so of all this, which one is better? So we cannot generalize which one is better. Okay, it's all have its own unique advantages and disadvantages. Anyhow, we'll discuss this later point in time, guys. Don't worry, okay? It is too early to discuss about everything. Now let us go ahead and explore the natural language